Alright guys, I know it's been a very long time. My apologies for that. I could come up with 1,000 reasons why I haven't finished the big power supply project, other shit like that. But you know, life happens. So, anyways, I mean, there's that there. There's that. Oh yeah, speaking of the big power supply, I just finished it. So, yeah, she's all done. All sorts of messy too, because I've had to, rewire the insides about 30 times and I'm running out of space. So, oh well. The whole messiness of it though kind of adds to, the whole DIY aspect of it, even though this is what I do also for work as control work. So it bothers me at the same time. I kind of like the look of it because it's something that just kind of reflects, doing whatever you want. But she's all done. She's all working. That button's missing because, the main button for the main contactor broke. So it's actually sitting on the floor right there. After I had to cut in the voltmeters. So voltmeters, amp meters are in. Everything's in. And this is the power cord coming in now. I managed to get a bunch of these for absolutely free. These are 50 amp twist locks. I actually do a lot of work at a big, well, whatever you want to call it, festival or whatever. So their generator guys leave these all the time. They just don't care, even though a set of these is like $500. They leave them all the time. So there's that. There's another one coming off. This one's used in a very improper way, as you can tell, because the ground ring is taped up. And that is because I'm using the ground on that as the wiper return from the actual Variac stack. So it's taped up so I don't, shock the ever living shit out of myself. So yeah. Now, that's all in. Those all work. This is supposed to be for was going to be for the 480. That wasn't working, so I shifted it off to be a 270 tap. And now the contactor's screaming. So, oh well. So I'm going to sit down in my chair right here and give a bit of a breakdown and sit on a screwdriver as well. So, power comes in here, right? There's that. Goes through the CT. And then that power comes all the way over into, well, you can't really see. Let me see if I can turn on. There we go. So, if I can, no, not really see, but right there's a decent view. So you have two contactors there, one contactor here, you have Big Bertha here. So you have 120, 240, and what's going to be for the 480 that I turned to 277. All those do is basically change taps on the Variac. So what it does is it shifts on the input side. Line 1 is always on that side. Well, it shifts it, which, yeah, I know it technically makes the voltage swing reversed, but whatever. Line 1 is on that side. And so it'll switch either neutral or line 2 there, or it'll apply on this side, it'll apply line 2 right here, which will put it as an overwind. So the tap is right there. You'd end up with about 20 turns of overwind or something like that. Because the specs on these, which is really hard to find sometimes for some reason, I used to have the data sheet on it and then I lost it and I'm having a hard time finding it again. These are General Radio Company Type 50B Variacs, because I guess General Radio Company is the one that coined that term. These are rated at 7.5 kVA a piece, and I know I've said that in the previous video, but I'm just going back over it. So this is technically 15 kVA rated altogether. Each one is only technically rated for about 25 amps a piece, is what General Radio Company states is what they're rated for. But you can push every bit of 35 amps through these, and they really don't complain. I mean, I just had them pushing about 60 amps between both of them, and they're not even warm. Like, I mean, yeah, it's going to take a long time for them to get warm because they have so much thermal inertia because how big they are, because each one weighs like 100 pounds. But, yeah, so then the wiper, which is, I love how the wiper is actually just the entire top plate that's insulated from the shaft, thank God. Then comes back through the main cable, comes into here. So then we have, so you can see the red right there, which is the overwind, goes to there. I just hit the screen instead of pointing, that's great. Goes to there. And then you have black and green are here. And then the white, which, I mean, it's really hard to actually point as to what's going where, but then the white comes back through, and the white is over there. So the white is basically the first, the start tap, the low tap, whatever you want to call it. And then the wiper comes here, and L1 comes here, and then that goes back out to the Variax. So because between your initial, or the white's your end tap, my apologies, your start tap is here, because your start tap between start tap and wiper, so between your low side tap and your wiper, is always going to be your voltage. So then those are, you can see the little wires coming off of it, that's for the voltmeters. And then on the other side of Big Bertha is the other voltmeter. So you have basically constant voltage reading, and then you have your output voltage reading. And those go through into a 50 amp plug. The top one is the, like I said in the previous video, the auxiliary plug. And then that all comes up, which this has been rewired. It still doesn't work quite right, because you can see all the contactors in there. This relay is removed to change some functionality. Main reason being that I wanted to make it where it's always going to use the ballast on the incoming until you tell it not to. But when you kick the ballast out, it doesn't really work right. So I got to figure out what the hell that's doing that for. But yeah, there's about, final count that there's about 32 relays in here. So you have all these ones up here which are driving the actual contactors. And then these are your basically final output driving. Basically this switches on and off when this one's the relay for Big Bertha, and this one was the relay to actually trigger the different stages, but I removed that off the final, so basically they're always going to turn on, and then the only thing that gets actuated is Big Bertha, which, if you're wanting to know, this is a 400 horsepower rated contactor, rated at 600 volts to break 550 amps. So yeah, you can see by that, you know, up to 220 kilowatts of power this thing can handle. Complete overkill, yes, I know, but you know, basically it's also a safety measure of if something shorts out, breaker doesn't trip, main doesn't trip, whatever reason, that will break no matter what, because that has a break rating of like 60,000 amps or something like that. It has a stupid high actual break rating is what it is. So, but yeah, without further rambling, let's get her powered up. So I'm gonna plug that in. I have to do that with both hands because they're big connectors, and then I'm gonna position the camera so that way you guys can see what the hell is happening. So give me a second. All right, hopefully that is a good view and you guys can decently hear me because I have you propped up on a shelf. So control panel, Variac handle, you can probably see it right there, and then the main show piece. So I'm gonna reach over, grab this stick. So basically, procedure, first safety, well actually your first safety is a key, but I just leave the key on all the time. First safety is a switch, second safety is this. Kicker on, 120, 240, broken. Simple as that. Variac set at mid position, volts previous, volts output. So basically before Big Bertha main contactor, after main contactor, amps input, amps output. Amps input is always going to be a lot higher because those Variacs are hungry for fucking power. Excuse my French, but like the amount of power those guys eat compared to what the output is ridiculous. Like their cores get saturated so easily. So all we're going to do is we're going to go kick that on. That's 120. You can see the needle barely. Oh, you probably can't see the needle because I can barely see the needle. But that's 120. Kick Bertha in. Ka-thunk. Now this is at 120. That's about 50 amps. And everything kind of gets angry. It's funny because the Variacs actually like vibrate. You can hear them just but like not an AC hum, like it's an actual like metallic vibrating sound. And also the wire for the transformer, even because it's 10 gauge, is actually jumping every single time I order. Which I don't just want to demonstrate how it's going. Breaks it like it's nothing, obviously. So, I'm gonna shift up a little bit more voltage. Oops. Yeah. That's pulling 50 amps off the transformer's pulling 50, pulling 100 amps off the breaker, which it means this breaker's about to trip. So yeah, disassemble everything. Which, yeah, that's the glory of the safety feature. So let me pick you up. So yeah, that's the glory of the safety feature. If you turn that on, which that stick's resting on the transformer, so it's fine. If I turn that on and I trigger everything on, if I need to shut off anything, I can hit that button or hit the switch and everything's dead. So that's how safe it is. But yeah, there's Big Bertha fully up and running. Hopefully I can start making some videos on actually blowing shit up. Because, well, that's going to be hilarious and awesome because I have the power to do so. I need to put a cart under her and put a cart under this guy because this weighs like 250 something pounds. I had to pick it up by myself off my workbench and set it on the ground. That hurt. And I had to carry those from my old shop, which is down there by the tree line, all the way up into this new shop. But yeah, and that's where the power cable goes. Plugs into the camper power cord because camper power cords use the same type of connector, and then plugged over into the wall. So, anyways, thank you guys for watching. I hope you like the newest update to the shenanigans of this. Hopefully I can get some more videos. Thanks to the people that have actually wanted to see the final progress of this, because I know, like, Variac Maniac, he had wanted to see some stuff of this, see me get it done, but been a while, but I said I'd eventually get it done, and I did. So, thank you all for watching, and I will catch you later.